So we are live. Hi everyone, welcome back to Codera. Today in this video we'll be discussing the problem that is LeetCode daily challenge for today, that is 5th of February. The name of the problem is merge k sorted list. Previously this problem has been asked in a lot of organizations like Facebook, Google, and it's also been asked in Uber, Amazon and Adobe. So consider giving me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, and then within some time I'll start with this question, right? So as I told you, like in this question what you'll be given is you'll be given k different k sorted lists, right? You will be given k sorted list, right? So you'll be given sorted list, and what you have to do is in the end is you have to return all the sorted list in the merged pattern, right? So what you'll be given is, let's say if I give you something like this, if I give you, let's say 1, 4 and 5, if I give you first linked list like this, so you'll be given k hi Samadhan. Why big fan, man? It's just okay. So if you have been given this, and if you, let's say you have been given something like a 2, 3 and 6, like something like this, right? If you have been given assume that you were given k sorted list, right? So you are given k sorted list, so assume that you have been given 2 sorted list. So if you were given 2 sorted list, then what will you do? You can say that you have one list as this and the second list as this. Then what you can do is you can combine these, right? You can combine these lists, and what you can get the sorted list, right? Like what you do is you first of all can make a new linked list, something like this. You have one pointer here, one pointer here. So what you'll observe is which is the smallest among this and this. So it is 1, right? And the linked list in itself is sorted. This linked list is sorted in itself. This linked list is also sorted in itself. So I see that 1 is the smallest among 1 and 2. So I'll write 1. Then what will happen? This will point to 4. Now among 4 and 2, which is smaller? So 2 is smaller. So I'll write 2. Okay. After this, what will happen? I'll move my pointer from 2 to 3. Now among 4 and 3, which is smaller? So 3 is smaller. So I'll add 3 in the node. Right, after that my pointer moves to 6. So among 4 and 6, which is smaller? So definitely 4 is smaller, so I'll insert 4. Once I've inserted 4, so my pointer moves to 5. Now if my pointer moves to 5, so what I can see is 5 is smaller than 6, so that is why I'll first of all insert 5, and then lastly this pointer is pointing to null, so this linked list is empty. Then I'll insert this node, right? So in this way it will get sorted, right? Is this approach clear to you guys? Like if I have been given let's say I was given 2 sorted linked list, right? If I was given 2 sorted linked list, then I could keep one pointer on the first linked list and the second one pointer at the starting of the second linked list, and in this way I could have added, right? Because each linked list is sorted in itself, so keeping a pointer one on the first linked list, another on the second linked list, and keeping a check on the each elements, comparing and then adding the new linked list, making the new linked list would help me, right? And in this way I'll get the sorted linked list, right? If this approach is clear, please give me a +1. Now another thing that I could do is, let's say that I was given a linked list like this. Let's say I was given something like this. If I was given 1, let's say 4 and 5, then let's say I was given 2, 3 and let's say 6. I suppose I was also given 7, 9 and 10, something like this, right? So suppose that I was given these 3 lists, right? Suppose that I was given these 3 lists. So I have been given what? K sorted list, right? K sorted linked list I have been given. So total I have been given here 3. Okay, the value of k is 3 here. So I have been given 3 sorted linked lists in this particular question. Now what I could do is I can safely say that I could first of all have all the nodes. One thing that I can do is I know the value of all the nodes. One value is 4, another value is 4, and like one value, this value is 1, this value is 4, this is 5, this is 2, this is 3, this is 6, this is 7, this is 9, and this is 10, right? So 1, 4, 5, what are the values I'm saying, right? 1, 4, 5, 2, 3, 6, 7, 9 and 10. These are the values that I have. If I have these values, then what I can do is, can I say that if I just add all the values, right? If I just have all the values, first of all, if I extract all the values and then I sort them, I apply a merge sort on them, right? I apply a merge sort on these all the data, right? I apply the merge sort algorithm on all the data, that is all the nodes data value that I have, and then I merge this list again, right? I apply a merge sort, and in the end I get a linked list, I get a combined linked list which would be sorted, right? Does that make sense to everyone? Please give me a +1 in the chat if that approach makes sense, right? Does that approach make sense? Please give me a +1, right? What I'm saying is, you know what is the data of every node, right? So what you do is, since you know that every node, each and every node is distinct, so it will be included in the linked list, right? So what you do is you simply insert all the nodes maybe into a linked list, right? Maybe you can make a linked list, or you can make any, you can store it anywhere in an array. And then what you do is, once you have all the nodes, so what you do is you have all the data, right? You have 1 4 5, you have 2 3 6, you have all the data, right? So you can simply say that maybe if you just make a linked list like this, right? If you can make a linked list, so you can do it like this, right? 1 4 5, then 2 3 6, maybe you can merge the complete linked list like this. And then what I can do is, if I have a particular linked list, if I have a complete linked list, then I know that I can sort that particular linked list with the help of merge sort, right? I can apply merge sort on that particular linked list, and that linked list will get sorted. So this could be done in nothing but n log n, right? Where n is the total number of elements. Does that make sense? Please write clear in the chat. Samadhan, you can write clear in the chat. Thanks for the compliment. Right? Does that make sense to everyone else as well? I hope that it does make sense, right? Just if you have all the elements, so you just can make a combined linked list, and then you can merge sort, you can apply merge sort on this linked list, and it will take n log n time. That is where n is all the nodes, right? N is all the nodes. N is nothing but the number of all the nodes in all the list, right? So like total here is what? One total, n is here 9. So total 9 nodes are there, right? Okay. Right, this is one of the ways to do it. Now if you have this way, so that's perfect. But can there be another way as well? Yes, there can be another way as well, right? If you know the concept is, now I'll talk about the approach number 2, right? One way was to have the linked list, all the elements, and then sort it, right? Apply merge sort on it, right? Have all the data and apply merge sort. Then let me talk about the approach number 2. In the approach number 2, what I could do is, in approach number 2, it is very similar to the concept of merge to sorted list. Okay, merge to sorted list, right? So what does this mean? If I know how to merge two lists, then I can merge all the list. But how, right? Let's say I have been given k sorted list, right? So let's say my k value is 3. So let's say if I'm given 3 sorted lists, so if I'm given 1, 3 and 5, let's say I was given 2 and then 4 and then 6, then let's say I was given 2 4 and 7 like this, and let's say then I was given something like 6 8 and 9, something like this. If I was given this thing, so assume that currently I was not given this thing, right? Assume that there are 3 lists given, but assume that this list does not exist, right? Assume that this last list does not exist. So if I have 2 sorted linked lists, right? If I have 2 sorted lists, then I know that in order of n time, I can merge 2 sorted lists, right? As I told you in the starting as well, that I can merge 2 sorted lists as well, right? How can I do this? One pointer would be standing here, one pointer would be standing at the start of this linked list, another pointer would be starting at the start of this linked list, right? Which is smaller? Like you have 2 lists, so you have one pointer starting here, one pointer starting at the head of the single linked list. Now which is smaller among 1 and 2? 1 is smaller, so I'll update with 1. Then what will I do? Now this pointer would be pointing to 3, and this pointer is pointing to 2. So which is smaller among 2 and 3? 2 is smaller, so I'll add 2, right? Next step, what will happen? Next step, I've added 2, so now this pointer moves to 4. Among 3 and 4, which is smaller? 3 is smaller, so I'll add 3, right? Now my pointer moves to 5 in the first linked list. What happens? I'm pointing to 4, I'm pointing to 5, which is smaller? 4 is smaller, so I'll update 4, and then this pointer moves to 7. Once it moves to 7, so this pointer is pointing to 5, this pointer is pointing to 7, so I'll update with 5 because 5 is smaller. Then this linked list has got empty, right? This linked list is done, right? 1 2 3 4 1 2 3 5 7 4 5 7, right? 4 5 7 1 2 3 4 5 7, because 4 is also there, right? I hope that's clear, right? So this is the linked list, right? It moves to the end, and then I'll add this, right? So in the end, both of the pointers would be pointing to null. That is the end of the linked list, right? So what happened with this approach, right? The concept was that I thought of merging 2 linked lists, right? I thought of merging 2 linked lists. If I merge this list and this list. So I got this list, right? Merging two sorted linked lists. It is nothing but a linear approach. It's a linear approach. I merged these two sorted linked lists and I did it in linear time. Now you have another linked list, that is this 6, 8 and 9, right? You have this linked list. So what you do is, now you apply the same concept, that is merge two sorted linked list. Now this linked list is sorted, this linked list, this combined linked list that I've got from the first and the second linked list is sorted, and this linked list is also sorted, right? So now again can I say that I can merge two sorted linked list, apply the same concept, right? Apply the same concept. So if I take two lists at a time, so in this way by the end I'll be able to combine all the lists, right? This would give me one list, then I'll get this list, right? In this question, concepts are required, merge sort, yeah, right? Now I can merge, right? I can also do it using priority queue. I'll be letting you know like how I can do this. So now one pointer would be pointing here, another pointer would be pointing here, right? So I'll update it 1, then 2, like it moves to 2, then it moves to 3 because it is 6, so that's why I can update all these. So 4, then 5, then 6, right? So what will happen, my pointer would be pointing to this particular node, right? So like what will happen, let me show you. So what will happen basically is, after 5 my pointer is pointing to 7, and here my pointer is pointing to 6. So among 6 and 7, which is smaller, 6 is smaller, so I'll update it with 6. Then what will happen, once 6 is updated, so the pointer is pointing to 8. Among 7 and 8, which is smaller, 7 is smaller, right? So I'll say okay. Now since 7 is smaller, so I have updated it, and now the pointer to this very first linked list is pointing to the end, and this pointer is pointing to 8. So I'll say okay. Now I'll add 8 and I'll add 9 as well, because this linked list had some element. Now after pointing to 9, it will point to 12, and then this way the linked list will get sorted, right? Does that make sense to everyone? If this makes sense, so please give me a +1 in the chat. What I'm saying is, the concept is to merge two sorted linked lists, right? If you have been given k list, right? You have been given k sorted linked lists, right? If you have been given k lists, so what you can do is you can merge two lists at a time, like this. If you were given 3 lists, right? This was the first list, this was the second list, this was the third list. So at one point of time I merged two lists, and those two lists became one list, right? And then I had this third list as well. So now this merged list, this complete list is one, and this list is another list, right? So I can again apply the concept of merging two linked lists, and this would help, right? Does that make sense to everyone? Does that make sense? Please give me a +1 in the chat if that makes sense, right? Does it make sense to everyone? Does that make sense to everyone? Please give me a +1 in the chat if it makes sense, right? And like the video as well, if this makes sense, right? The concept is nothing but merging two linked lists, right? The concept is the same. You take two linked lists at a time, you merge them, you get one complete entity, one complete linked list, and then the next linked list which are left, you keep on merging them, right? Taking two at a time. This is the concept. Now for this particular approach, what will be the time complexity, right? So for merging, for what I'm saying is, what you are doing, right? What you are doing is you are applying the concept of merge two sorted list, right? So you are merging two lists at a time, and total there are k lists, right? Total there are k lists, right? So for applying this operation one time, hi Shreya, is this approach clear to you? I hope that it's clear, right? Merge, if applying for merging two sorted linked lists, the time complexity would be order of n. It would be linear, right? It would be linear. Now if I want to merge k list, then can I say it would be nothing but order of n into k? Does that make sense? Right? I hope that it does make sense, right? For merging two lists, I'm taking a linear time, I'm taking order of n time. So for merging two lists, if I'm taking order of n time, then for merging k lists, I'll take n into k time. It's very simple approach, very simple unitary method, that for merging two lists, if I'm taking n time, so merging k list would take n into k time. So this would be the time complexity. Please write yes in the chat if this is clear, right? So this was nothing but the approach to. Right? First approach we discussed was very much basic. You have all the data, you completely have all the data, you collect all the nodes data, and you just sort it using merge sort n log n, right? First approach was taking n log n time because you were applying merge sort, but we said that since we can merge two lists in a time complexity of order of n, so if you have total k lists, so the time complexity would reduce to n into k, right? Okay, this could be the approach. Now the third approach could be also there, right? There could be a third approach to this particular problem as well. Let me show you the code first of all, like how will you implement the merge list concept. So what you will be doing is, basically if the list that has been given to you, if it's empty, then you return null. Otherwise, if the list size is greater than 1, right? What I'm saying is I need at least two lists to merge, right? I need at least two lists to merge the list, right? So I'll pass a function that is merge to list, right? So this is nothing but this will take order of n time to merge the list, right? I'll be telling you how. So I'll pass the linked list 0 and 1, right? And what I'll do is I'll erase the linked list, beginning linked list and the ending linked list, right? So what does it mean? So if I say, suppose that I had linked list like 1, 3 and 5, and I had 2, 4 and 6, right? If I have these two linked lists, and let's suppose I had another linked list that is, let's say 8, 9 and 10, something like this, right? So if I am merging this linked list and this linked list, so this linked list, sir, one request to you, please provide Java solution also. I watch your every video, but solution in CPP. Okay, so feedback is noted. I'll provide the Java solution as well from now on. Okay, Samadhan, you can depend on me. I'll provide you the Java solution in the description as well from now on, right? So I have this particular, if I have this linked list and this linked list, so what I'm saying is now I'll not consider this into my list, right? Now what I'm getting is I'm getting this as a complete entity, right? Both of them are merging, right? So this will not exist independently, this will not exist independently. So I'll remove this from the linked list, from the k list I'll remove this and this as well, because I'm getting a complete entity that is 1, 3 and 5, right? Not 1, 3, 5, but basically this thing 1, 2, 3, 4, 5. Let me write it like this, right? 1, 2, 3, 4, 5 and 6, like this, right? And if I have 8, 9, 10, right? So now you can see that this particular linked list does not exist independently, right? Okay, this particular linked list does not exist independently, and this particular linked list also does not exist independently. So I'll erase it. If I erase this particular linked list, so I'll write erase L of 0, right? Erase L of 0 or linked list dot begin. So this linked list would get erased, right? So this linked list would get erased. So if this linked list gets erased, so this will now be the beginning linked list. So I'll erase this one as well, because this is the new linked list that I am getting, right? So this is the new linked list that is getting added, and I have this linked list as well. Now I'll merge these two, right? If I'm merging these two, so this will also not exist as a single entity. This will also not exist in a single identity, because in my list I'll be updating it with a single linked list, right? So this is what I'm doing basically. Please give me a +1 in the chat if this part is clear. Like what I'm doing is if the linked list, this linked list is storing all the linked lists, right? So if the linked list, if there is more than one linked list, so in that case I'll keep on doing the merging part, right? Like in this case, how many linked lists I had one linked list this, second linked list this, third linked list this. But after the operation, I said that I will be deleting this from the original data and deleting this linked list as well. So now I have a combined linked list. So this is one linked list, this is the second linked list, right? So now I have two linked lists. Then what will happen? These two will get merged and I'll have one linked list, and I'll erase this linked list and this linked list. So only one linked list is there. If only one linked list is there, that means that is the linked list that I wanted. That is the final linked list, sorted linked list that I wanted. And if I have more than one linked list, then only I'll be performing the merge to sort linked list operations repeatedly, right? If I just in the end I have just one linked list, then at that point of time immediately I'll stop the merging part, right? So this is what I would do, right? Now what I'm saying is, like as I told you, like I'll push back the linked list that I have merged. This function would return me a linked list, right? This function would return me a linked list. So what I'll be doing is this, whatever merged linked list that I am getting, what is the merged linked list that I will be getting? The sorted merged linked list, right? That I'll be getting from the function merge to sorted list, right? So whatever I'll be getting, I'll be pushing into my lists, right? The linked list that I am having, for which I have to make a complete single linked list, right? So I'll erase the first linked list and I'll erase the I'll erase the first linked list, right? So I'll erase this linked list, that is 1, 4 and 5, something like this, right? 1, 4 and 5 would get erased. Now since 1, 4 and 5 gets erased, so now the linked list 2, 3 and 6 would be the 2, 3 and 6 linked list that was there. It would be what? It would be my first linked list, so that's why it would be the beginning linked list. So I'll erase it as well. So I'll erase it. So that means that after this operation is performed, only one new linked list is getting inserted and the two older linked lists are getting erased, right? Once this operation is performed, then I'll return the front of the first list, right? Because that would be the list that would be the just combined one single linked list, right? So let me show you how I'll be merging. So if the first linked list is pointing to a null, so in that case I'll return the second linked list. If the second linked list is pointing to a null, that means I'll return the first linked list. If that is not the case, so if the first linked list is pointing to a pointer, if the first linked list is having a value which is lesser than the equal to the value of the second linked list at which the pointer is there, so I'll say that okay, L1 next is equal to merge linked list X, right? This is a recursive function that I'll be calling, because since this is a linked list, right? So this is nothing but, as I told you, the pointer, right? Whichever element is smaller, I'll be adding that first, right? If the second linked list element is smaller, so I'll be updating that. So this is what I would be doing, and in this way this function would be done, right? Okay, now another approach could be using merge sort, right? So let me tell you this part, right? Is it clear to everyone? I hope that it's clear, right? Now there could be approach 3. Approach 3 could be using priority queue, right? Approach 3 could be using priority queue, and what you could do with this priority queue is you could have a priority queue. Basically there's some noise, so that's why I'll have to end the session a little bit earlier today, because I don't think it will allow me to do that, right? So what I want to say is that if I have a particular linked list, right, so I can use a priority queue. Like, how does a priority queue help me? So what I'm saying is, in a priority queue, it will help me to do the job in nothing but order of n log k time. Why n log k time? Because I'll at one point of time, whatever priority queue I'll be having, right, whatever priority queue or the min heap that I'll be having, min heap or the priority queue is nothing but it will be having k nodes, right? So if I have k, what I'm saying is I have k list, right? Yeah, they, like, sorry for that, like, that is why I delayed the this live stream today instead of 2. I delayed it, but still, just bear with me, just bear with the voice, like I cannot do anything with that, okay? So you can just bear with me, right? So if there is a k list, right, if there is a k list, so what I have to do is my voice audible? Is my voice audible, right? Is it clearly audible, or is there some issue? Should I end the stream here or should I continue from here, right? Because I have to tell the third approach. According to that, you can tell me, right? Should I end it? Is it feasible? I hope that it is, right? So like, I have a k list, right? I have a k list. You guys can enjoy the vibe behind, right? कोई नहीं सर चलते हैं. Yes, okay, right? So like, if I have a k list, so what I have to do is, if I have a k list, right, if I have a k list, you can do this, like, okay, so if I have a k list, right, so if I have a k list, so what I can do is I can have a priority queue, right? I can have a priority queue. How does it help me, right? So what I am saying is, at one point of time, every element would be giving me 1, like if I have 1, 3 and 5, and if I have, let's say, 2, 4 and 6, like this, and if I have another list, like, say, let's say what it was, let's say I have 7, 8 and 9, something like this, right? If I have this, all these things, right, if I have all these things, right, so what I can do is I can say that each of the linked list would be contributing at least one element at one point of time. So what I can do is I can make a priority queue, okay? I can make a min heap. I can make a min heap or a priority queue, since I am having k list, right? Since I am having k list, so what I'll have is, what is the first node here? The first node is 1, so I'll insert 1 here. What is the first node here? It is 2, so I'll insert 2 here. What is the first node here? It is 7, so I'll insert 7 here, right? So at one point of time, not more than k elements are there, right? Not more than k elements are there in the linked list, right? So that is, here is 1, here we have 2, here we have 7. So one element from each list is what I'm having. So the size of the min heap or the priority queue is k. At most the size is k. So every time one element from each list would be present, right? And because each linked list is sorted, so I can take care of it. Like, what now, earlier what was happening, the time complexity was n log n, right, combined. But now this priority queue, the heapify process, right, since I am having only k elements, right, in the min heap I am having only k elements, right? And if I am having only k elements, so what does that mean? If I am having only k elements, so the heapify process in the min heap takes log of k time, right? If there are k elements, so that is how it's helping, right? Let me tell you how. Okay, so what I would do is, I have this one, so I'll insert one, right? Because 1 is the smallest element among these, so I'll insert 1 and then I'll remove 1, right? Instead of 1, now which element I'll be putting? I'll be putting 3, so I'll put 3. Now 1 is there, now which is the smallest element? The smallest element is 2, so I'll say okay, now the 2 will be there, right? Once 2 is there, so what I'll do, I'll remove 2, and since 2 was coming from this particular linked list, so I'll have the pointer to it. So now I'll insert 4, so I've inserted 4. Now this would get heapify again. Every time I am adding a new element, so notice that the min heap size is not more than k, right? Is this much part clear to everyone? Please give me a +1 in the chat if up till now things are clear, right? So the min heap size is not more than k, right? So I have inserted another element, so I've inserted 3, 4 and 7, so which is the smallest element? The smallest element is nothing but 3, so I'll say 3. Okay, so now since 3 is there, so what I'll do, I'll update it, and now 5 would be there, right? 5 comes into the min heap. Now if 5 is also there, so again the heapify process will take place, right? And it would take log of k time, okay? Because there are k elements in the min heap, right? One element, one representative from each linked list is there, right? One representative from each linked list is there. So that basically means that the heapify process takes, if there are n elements in the heap, so it would take log n time, right? So if there are total k elements, so it will take log k time for the heapify, right? The heapify process, which means that if you are inserting a new element and such that the size is not more than k, so it will take log k time, right? Does that make sense to everyone? I hope that it does make sense, right? Please give me a +1 and please like the video, at least for the whole and everything. You can like the video, okay? Right? So still I'm trying to make the video, right? So what I'll be doing is, like, I have all these elements, so which is the smallest element? The smallest element is 4, so I'll insert 4, and what I'll do, I'll remove 4. Now I'll instead of 4, 6 should be inserted, so I'll insert 6. Heapify process is again taking place, so 5 is the smallest element in the min heap now, so 5 would be there, right? Okay, thanks a lot, Mahesh, right? So 5 is there, right? Once I have 5 here, so 5 is there. After 5, this points to null, right? Take it easy, yeah, right? Thanks, yeah, right? So if I am pointing here, I am pointing to null, so that means that this linked list part is done, right? So I'll say okay. Now this linked list is done. Now which is the element that I have? I have 6, so I'll say okay, I have 6, so I'll insert it, right? So it will look like this. Now 6 is done, so this linked list is now pointing to null. This pointer is pointing to null because the second linked list is empty. Now what will happen? I have 7, so I'll insert 7. Now after 7 I have 8, so I'll insert 8 here, and 8 would get inserted. Now the pointer would be pointing to 9, so I'll point to 9 as well, right? So this is how it would be looking like. In the worst case, if I have to tell you, like, is this approach clear, right? So what I'm saying is, every time in the heap, like one element from each linked list is there, right? One element from each linked list is there in the min heap, so that means total k elements are there in the min heap, right? Total k elements are there in the min heap. If total k elements are there in the min heap, so what does that mean? If total k elements are there in the min heap, so there is a heapify process that takes place. Heapify process takes place, that takes nothing but order. If there are k elements, so it will take log of k time for each time to heapify, right? Heapify means that the bringing the minimum element up to the top, right? So it will take log k time, right? And what I'm saying is, total there are n elements, right? Total there are n elements. Suppose that all the elements combined, all the elements of the linked list combined, there are total n elements. If there are total n elements, then for one element, for adding one element, let's say I had some elements, right? Let's say I had one, I had what? Let's say I had one, I had let's say 4, and I had 7. One element from each linked list, right? If I remove this one, then I'm inserting 2. So each time I'm inserting a new element and removing one element, so that process is taking log k time to heapify, right? So if for one element, for inserting one element, it is taking log k time. For one element, if the heapify process in the min heap for one element is taking log k time, right? K element is what? Each k element means, in the min heap, k element means one element from each list, right? So if for one element it is taking log k time, so for n elements it would take n log k time. Does that make sense? Does that make sense to everyone? Please give me a +1 in the chat if that makes sense, right? then I'll be showing you the code as well. If it's not clear, anything is not clear, you can let me know, and you can like the video as well, right? Does that make sense to everyone? Does that make sense? Is it clear? I'm waiting for your replies in the comments. Then I'll proceed further, right? Does this make sense? The priority queue concept or the min heap concept, like each representative from one layer, from each you have k representatives, each from one list, right? One list. Like if you have, let's say a list like what, 1 4 and 7, let's say, and let's say you have 2 11 and let's say 13, and let's say you have something like a, let's say something like a 5 and then 10 and then 20, something like this. So you have one representative from each, like one representative from here, one representative from here, and one representative from here, one ambassador from here, one ambassador from here, one ambassador from here, right? Okay, so that means k elements would be there. At most there would be k elements. So the heapify process for one time would take log k. Okay, and you will be inserting, in the worst case you will be inserting l elements, right? You'll be inserting like n minus 3 elements, but that would be n elements, right? Because n minus 3 elements have already been inserted. So like 3 elements have already been inserted, so you'll be inserting and n minus 3 elements as well, the leftover n minus 3 elements, like this and this, all this will be getting inserted in the later part, right? So that will take the heapify part, right? First solution is ed, then second, and then third. Yeah, that's why I've taken it like that. Okay, so like this would be n minus 3. So it's, if n value is very large, so n minus 3 would be nothing but n. So if for one element the heapify process is taking log k time, what is the heapify process? Heapify process is nothing but in the min heap. It is the heapify process in the min heap is nothing but it is time taken, that is log k time is taken to bring the minimum element at the top of the heap, right? So that's what it does. So if for one element it is taking log k time, so for n elements it will take n log k time, right? Does that make sense? So for, let me just give you a summary, right? Let me just give you a summary, right? Let me just give you a summary of this particular session. So what I said was, the first approach that we could do was like have all the elements, right? Insert all the elements, have all the elements, right? You have all the elements and apply merge sort, right? Apply merge sort to get a combined sorted list, right? And that would take nothing but order of n log n time, where n is the all the elements, right? N is the total elements, all the elements that I have. Now the second approach was that I use the concept of merge to sorted list, right? Merge to sorted list. So what is this merge to sorted list concept? In the merge to sorted list concept, I was merging two lists at a time. For sorting two lists, for merging two lists, it takes order of n time in the worst case. That is a linear approach. So since I had k list, for merging two lists, if I'm taking order of n time, so for merging k list, I would take k into n time. This is also making sense. Now in the third approach, what I said was I could use a min heap, or you can say a priority queue, right? I could use a min heap or a priority queue, right? And how will it help me, right? How will it help me? So I'm saying that in the priority queue, one representative each from each linked list, one representative would be there. So that means that the size of the size would be of the priority queue would be k, and if the size is k, so the heapify process takes log k time, right? And there are n minus 3 other elements that you will be inserting as well from time to time. As I told you, you can just move back, you can scroll back and see the video, right? So that means if I have n element, if for one element it is taking log k time, so for n elements it will take n log k time. Does that make sense? If it makes sense, so please write a +1 in the chat. A +1 would encourage me to bring such detailed video editorials for all of you, because I think that is the gap that we have on YouTube. Like, people do provide you solutions, but they do not provide you the intuition behind that. What's the logic? Like, if you were in an interview and if you see this problem for the first time, then how would you approach it, right? So n log k, right? So this is how it would look. Let me show you the code part for that particular approach as well. Like this is nothing but what I'm doing is compare. So this, like, whenever I declare a priority queue, so I have to declare it like a min heap or a max heap, right? So here, as I'm declaring a priority queue of a linked list, right? As I'm declaring, you, thank you Mahesh and thank you Samadhan, right? So as I'm declaring a priority queue of list, right? So what I have to do is I have to compare, I have to put a compare function. What is this compare function? This compare function is nothing but to make a mini heap, right? So this is how you can customize your mini heap, to make a mini heap for a linked list. I hope that this declaration is perfect for someone who is doing C++. He would be perfect. If someone is doing in Java, so you can check out the approach, like how you can declare a mini heap in Java, in Java, right, or any other language. So what I'll be doing is I'll be pushing the all the like I'll be doing what, I'll be pushing first element of all the list into the priority queue, and until the priority, if the priority queue is empty, then I'll return null. Otherwise I'll take out the top element, and what I'll do is I'll simply if the next element is existing, if the top element is existing, then in that case I'll push its next. Otherwise what I'll do is I'll have the tail, right? So this is nothing but, as I told you, right, approach that I told you, that if the priority queue, you have to keep a check, right? You have to apply a priority queue approach, like every time you, whenever you take out a top, so from that same linked list you have to get that particular thing back, right? So that's what you have to do. So this is what you have to do, and this was the code for this approach. I'll provide the every code in the description. So thanks a lot for watching this video, and now tell me if it's clear to you or not. Now also telling you a little bit about the future live streams. So today we have a LeetCode bi-weekly challenge, right? LeetCode bi-weekly challenge. So I'll be making 4 editorials of that. Tonight only I'll be publishing it. Now tomorrow morning we have LeetCode weekly challenge, right? Weekly challenge. So I'll be making 4 editorials of that also. And tomorrow evening, like Sunday evening, we have codeforces div 2 round, right? So I'll be making a video edit div 2 round. So I'll be making 3 to 4 editorials of that as well. So this is what we have planned for you. You can definitely consider to share this channel with your friends. You can maybe share it as your WhatsApp status or something. If you think that we are able to bring a change, if you are able to change the way programming is being taught, or the problem solving skill is being taught, right? So thanks a lot for watching this video, and if you have any feedbacks after this video is over, so you can after this video is over, you can just comment down your feedback, like how did you like the video. I'll provide the timestamps as well after this video is over. Thanks a lot for joining in, and I'll see you soon in the next live. Till then, take care and keep coding. Thank you.